So in this question we have to find the maximum speed of the block. This is block and maximum elongation of the spring. So in this question, when we apply a force, the block will move on the front at instant time t, and it will decelerate after time t1. So when the force is applied, the block it accelerates for some time, then it is decelerate. Therefore, the acceleration of the block is initially positive, then it will become zero, and finally become negative. So in terms of mathematical expression, a of x is equal to 0. F of x is the acceleration at the time 0, and f of x is 0. So initially there is all the force and acceleration is 0. So we can write the equation as f minus kx is equal to 0 and x is equal to f by k. X is the maximum elongation of the spring. How much it can be extend. It is like that. So after applying a force in terms of mathematical expression, we know that the maximum speed, to find the maximum speed, let us use the work energy theorem. So work energy theorem states that the total work is equal to the change in kinetic energy. So Ws plus Wf. Ws is the work done by the spring, and Wf is the work done by the force, which is equal to half mv square minus 0. So work done by the force initially at 0. That is why we write half mv square minus 0. 0 is came from initially at 0. So in terms of integration, we can write it as 0 to x. So we replace x by f by k. So we put the value of x over here, f by k, into kx dx into 180 degree, plus half 0 to f by k into f dx. This is a work done equation of work done by the spring plus work done by the force. That's why we take half integral over kx dx plus integral over f dx. By solving the integration, we will get half mv square minus f square by 2k plus f square by k, which is equal to half mv square, or in terms of v, you can write v maximum velocity. V is a velocity. Maximum velocity is equal to f square by mk. So when the elongation becomes maximum, the block again come to rest. So therefore, from the work energy theorem, we will get force of the spring, work on the spring plus work on the force equal to 0 minus 0, because the elongation became maximum, the block again come to rest. That is why we will get 0 minus 0. So in terms of integration, we can write as 0 to integral over x0 plus kx dx plus cos 180 degree plus 0 to x0 plus f dx is equal to 0, because in terms of integration we are writing this equation equal to minus half k square plus fx is equal to 0. Because of what? By solving the integration over 0 to x0 plus 0 to x0 f dx, we will get minus half k square plus fx is equal to 0, and the value of x0 is equal to 2f by k, because x0 is the maximum elongation of the spring. So we get the answer of elongation of the spring, and in the question they asked find the maximum elongation and find the maximum speed of the block. So we already find the maximum speed of the block is v is equal to root of f square by mk. So this is the solution of the this questions.